Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Kita sambung lagi berkenaan topic of integrations. We continue with topic 7.5 area of region. Okay, in this case, we are going to talk about a region which bounded by a curve of fx, okay, of fx, x-axis, and two lines x equals to A and x equals to B. So bounded ni bermaksud dalam kes ni adalah merupakan kawasan yang terkepung oleh curve yang dimasukkan tadi. Kita ada fx, kita ada x-axis, we have x equals to A dan x equals to B. Okay, baik, kita tengok yang pertama. Let's say that we have a fx. Let's say that we have a functions of fx which continuous, and our fx is greater or equals to 0 for all x in between A to B. Okay, and let's say that we're looking for a bounded region which is bounded between a curve of fx. So this is actually fx, and also we have x equals to A and x equals to B, and we also have the x-axis. So the regions that we are looking for in this case adalah merupakan bounded between all this curve. Okay, so this is actually a region R that we are looking for. Basically, in this case, kita akan guna basic of definite integral, whereby kita akan lakukan the integral of fx dx, and we have a limit from B to A. So since we have a vertical line of x equals to A and x equals to B, so yang ini kita akan gunakan basic of integral yang biasalah, iaitu kita akan integrate fx dx, dan our limit is actually BA. And we have a second case where we have fx is less or equals to 0, whereby f also is a continuous function. Okay, and then so katakan dekat sini a bounded region between a curve of fx. Okay, so this fx, and we have a straight line of x is equals to A, x is equals to B, and also the x-axis. So this is actually a bounded region that we're looking for. Okay, region. Alright, but this case kali ni kita akan lakukan integrations of these functions of fx. Okay, fx with respect to x. Okay, kita akan lakukan fx dx. Okay, and we have a limit from B to A, but this time since the region is actually lying on the negative sides, kita akan dapat nilai dia adalah negative. So since we are looking for area, so kita akan letak nilai, kita akan letak absolute. So that means that we're just taking a positive value. Okay, and then lastly we have kita ada case di mana kita ada di bahagian positif dan negatif, di mana gambar rajah ni. Okay, so let's say that we have the range of fx is less or equals to 0 for x less than c. Okay, so we have this one. So kita ada yang ini. Okay, kita ada region yang ini dengan x-axis. Okay, then we have fx is greater or equals to 0 for x is greater than c. Okay, so we also have this part. Okay, fx also with x-axis, but this time our fx is greater or equals to 0, and we have x is greater for x is greater or equals to c. So this is actually the region that we're looking for. So kali ni kita ada positive dan negative region. So in this case, kita akan kategorikan sebagai, so let's say that this one is the region of A, and this is actually the region of B. So therefore kita akan ada A plus with B equals to, so we have a modulus. So since yang region A, okay, we are going to integrate a function fx, okay, with the limits from A to C. So in this case we are going to have a negative region, so kita letak nilai absolute. Okay, sebab kita nak ambil nilai positif saja. Plus with integrate, okay, from fx dx with the limits from B to C. Okay, so this one definitely positive, dan kita tambahkan dia saja, and kita akan dapat the regions of the shaded regions bounded between curve and the x-axis. Okay, so untuk yang ketiga ni, dia melibatkan hanya function fx dengan x-axis sahaja. For function 1 and 2, kalau kita tengok kat sini, dia melibatkan function fx and also x-axis, and we have a vertical line which is x equals to a, x equals to b for both examples. Okay, now kita tengok bahagian di mana kita ada area of region bounded by a curve of fy is equals to x. Okay, fy is equals to x with y-axis. Kali ni kita nak tengok dengan y-axis, and two lines of y is equals to a and y is equals to b. So these both are horizontal line in this case. So kita tengok contoh yang pertama. Consider the graph of f, the continuous functions where fy is greater or equals to 0, means they are berada di bahagian first quadrant, which is a positive side, in a closed interval of ab. So ab in this case is actually y. Okay, it is a range of y from a to b with closed interval, which means a and b are included. So to find the region bounded between the curve of f, okay, so we have the curve of f and the x is equals to a, and then y is equals to b, and then we have the y-axis, okay, bounded between all of this, kita akan dapat this region. Okay, so let's say this is a region R. So how to find this? We are going to integrate of fy. So let's say that we have a function in terms of x, kita nak kena simplify dia in terms of y untuk kita lakukan process of integration. So after we simplify in terms of y, we are going to integrate with respect to y, and we have a limit from a to b. Okay, so kita lakukan seperti mana kita finding the area under the curve, okay, between the limits of a, b. Yang kita tengok yang kedua, let's say that we have a case of fy which is less than 0. Okay, kita ada di mana dia less than 0, bermaksud dia akan berada di bahagian negative side, okay, which is on the second quadrant. Alright, so in this case sama juga, kita akan lakukan process of integral. So kita tengok the regions that involve, which is this is actually fy, and we have okay, this is, let's say this is b and a, and this is actually y. Okay, y is equals to b, y is equals to a, and the region involved is y is equals to b, y is equals to a, and the y-axis. Okay, so this is the region that we're looking for. Okay, region R. So in order to find this, we are going to integrate with respect to y, which is fy dy, and the limit is actually from a to b. And of course, this thing, since it is less than 0, which is a negative value, kita akan letak absolute value, because we are consider a positive value saja untuk dapatkan area of these functions of fy, of this bounded region. And lastly, the same thing, kalau kita ada graph of fyx, which kita akan ada di positive and negative side, okay, kita akan bahagikan kepada dua area. Okay, so katakan dekat sini we have a function of fy with x, okay, with y-axis, and also we have y is equals to b. So we will have the first region, katakan dekat sini saya setkan this region is equals to b. Okay, b, which means this is actually on negative side, kita akan letak nilai positif, kita akan letak absolute. Okay, then function of fy with with y-axis, and also y is equals to a, we are going to have a second region on the positive side, which is kita letak dia sebagai a. So means in order to find this region of R, okay, kita akan tambahkan dua region ni, which is a plus b. So the first region for a, so this is a. Okay, so we're going to have fy dy, kita akan integrate fy with respect to y, and now we have a limit from c to a, from a to c. Okay, Then we have C to A, so it is a positive side. Definitely we're going to have a positive side. Plus with, now for B, okay, for B, so we're going to do the same thing, which is we are going to integrate with respect to Y. Okay, sorry. We're going to integrate with respect to Y, and we have a limits from, we're going to have a limits from C to B. Okay. Then in this case, since B is actually lying on the negative side, kita akan letak absolute untuk kita dapatkan positif nilai dia. Okay, untuk kita kira area of this region. Alright. Okay, so let's start with first example. Find the area of the region bounded by the curve fx equals to 1 over x minus 1, x is equals to 2, x equals to 5, and x exists. So before we start finding calculating of the region bounded between all these things, first let's start sketch the graph of fx equals to 1 over x minus 1. So we know that for fx equals to 1 over x minus 1 is a reciprocal, okay, reciprocal graph. So for reciprocal graph, we are going to have a restriction. Kalau pelajar-pelajar masih ingat, kita akan ada restriction. Okay, restriction di mana x minus 1 kita tak boleh sama dengan kosong. Okay, so this cannot be equals to 0. So from this restriction, okay, we simplify. We're going to have x cannot be equals to 1. So therefore, we are going to have asymptote line. Okay, asymptote line at x is equals to 1. So from the graph, we know that. Okay, so we're going to have a graph y, x, and we have the asymptote line x is equals to 1, whereby the graph will not be cross this line. Okay, dia takkan cross line x is equals to 1. So this is the graph it look like for function of x. Okay, and also kita akan sketch line of x is equals to 2. So kita akan ada x is equals to 2, and also x is equals to 5. Okay, and the x-axis. So now we are looking for the region bounded between these four things. The first one is fx. Okay, so the first one is fx. Okay, and then x is equals to 2. Okay, and then x is equals to 5, and lastly is the x-axis. So bermaksud the region that we're looking for here is this part. Okay, part yang ni. Alright, so this is actually the region that we're looking for. So to find the region of this bounded, we're going to do the definite integral, since it is involved with function of x and the x-axis. Okay, so this will become our limits of integral x equals to 2 and x equals to 5. Jadi kita akan kira, okay, integral of from 5 to 2. So we have a functions of 1 over x minus 1 dx. Okay, so since 1 over x minus 1, we are going to have ln absolute x minus 1. Okay, we have a limits from 2 to 5. Okay, then kita masukkan nilai limits kita akan ada ln 4 minus with ln 1. Okay, so we know that ln 1 is actually 0. So therefore, our final answer, okay, final answer in this case is actually ln 4. So means that area of the region, okay, is ln 4 unit squared. Okay, kita akan letak ni unit squared. Okay, so this is actually a final answer for example 1. Okay, let's move to example 2. Sketch the curve fx equals to x times x minus 2 times x minus 5. Hence, find the area of the region bounded by the curve and the x-axis. Alright, so first of all kita nak kena sketch graph fx. So we know that this fx is actually a cubic graph, x to the power of 3. It is a polynomial function. So untuk sketch graph, benda yang pertama sekali kita akan buat is for this fx, okay, kita ada fx is equals to x times with x minus 2, x minus with 5. So kita akan tentukan x-intercept, okay, x-intercept of this curve, di mana kita akan setkan fx is equals to 0. Kita akan dapat x times x minus 2, x minus 5 is equals to 0. Therefore, our x is equals to 0, 2, and 5. Okay, so this is actually our x-intercept. Okay, so from this x-intercept, kita dah boleh illustrate how the graph is look like. Okay, so our graph, we're supposed to have okay, something like this. So this is y-axis. Sorry, so saya tukar ni, saya letakkan di sebelah sini sikit. Alright, so this is y-axis and x-axis. So our x-intercept will be at 0, 2, and 5. Okay, so our graph it will looks like, mungkin dia akan berbentuk seperti ini. Okay, okay, ataupun graf tersebut mungkin berbentuk seperti ini. Okay, so we have two types of graph. Dua-duanya adalah cubic. Okay, now in order to determine which one it is, sama ada dia from the 0 to 2, it is lying on the, berada di bahagian positif ataupun negatif of y. Okay, apa yang kita akan buat dekat sini adalah we are going to do a number line. So saya akan buat number line. Okay, 0, 2, and 5. Okay, 0, 2, and 5. Okay, so dekat sini saya akan ambil from the interval 0 to 2. So I'm going to take the value of x is equals to 1, and here I'm going to take the value of x is equals to 3. Okay, so this will be my test point in order to know whether it is positive or negative. So kalau dia positif, bermaksud graf kita akan ambil yang berada di atas. Kalau dia negatif, bermaksud kita akan ambil yang di bawah. Okay, so let's start with f1. Okay, so kita akan gantikan 1 dalam function fx. So kita akan dapat 1 times with 1 minus 2 become minus 1, and 1 minus 5 become minus 4. Okay, so which is we are going to have so this one is 1 minus 2 is minus 1. So we are going to have 4, which is a positive value. Okay, so kita akan dapat positive value. So means that this one kita akan pilih yang positif. Dan for f3, okay, kita gantikan dalam function fx. Kita akan dapat 3 times with 3 minus 2 become 1, and 3 minus 5 become minus 2, which is we are going to have negative. So negative means that kita akan pilih yang berada graf yang berada di bawah. So therefore graf yang terbentuk dekat sini adalah okay, so graf kita adalah merupakan bentuk ni. Okay, so this is the graph that we are looking for fx. So yang ini adalah merupakan graf fx untuk function x times x minus 2 times x minus 5. Okay, so now kita nak dapatkan region bounded between curve and also between curve and x-axis. So this is actually the region that we're looking for. Okay, so on the positive side and also on the negative side. So kita ada dua region. Okay, kita ada dua region. Alright, so katakan dekat sini saya letakkan dia sebagai A dan juga B. So we know that for region A is a positive of integral. Kita akan dapat positive of integral. And this one is actually a negative of integral, whereby kita akan letak nilai absolute value sebab kita nak dapatkan nilai area actually. So in order to calculate area of this region, okay, so area of this region, area of the bounded region, okay, so this will be equivalent to A plus with B. Okay, so means that our A plus B will be equals to, okay, integral of from the limits of 0 to fx dx plus with absolute value. So kita akan letak nilai absolute value. So we're going to have integral from 2 to 5 fx dx. Okay, so for this fx, sebelum kita lakukan proses integral, saya akan expand dahulu nilai fx kita. So now our fx, okay, kita akan ada x times with expansion of these two factor. We are going to have x squared minus 7x plus 10. Then we are going to have fx is x to the power of 3 minus 7x squared plus 10x. Okay, so now we are going to integrate 0 to 2 x cubed minus 7x squared plus with 10x. Okay, dx plus with, okay, right, sorry. Okay, so plus with we have absolute value. Okay, so integral from limits 2 to 5, we have x cubed minus 7x squared plus 10x dx. Okay, so integrate of this function fx, kita akan dapat x kuasa 4 bahagi dengan 4 tolak dengan 7x kuasa 3 bahagi 3 tambah dengan this one, we will become 10x squared over 2. Dan bila saya simplify, saya akan dapat 5x squared. So we have a limit from 0 to 2. Okay, plus with absolute. So I'm going to have the same x kuasa 4 bahagi dengan 4 tolak dengan 7x kuasa 3 bahagi dengan 3 tambah 5x squared. Okay, 5x squared. Okay, and here saya akan ada limit from 2 to 5. Okay, absolute value. Then okay, substitute the value of limits. Here saya akan ada nilai 16 over 4 minus with 56 over 3 plus with 20. Okay, minus with 0. Alright, and then plus with sini substitute the value of 5. Saya akan dapat 6 to 5 over 4 minus with 875 over 3 plus with 1 to 5. Okay, minus with 16 over 4. Okay, minus with 56 over 3 plus with 20. Okay, so now by calculating all of this dengan menggunakan calculator, we're supposed to have 21 1 over 12 units squared. Okay, so this will be a final answer untuk soalan ni lah. Okay, alright. Okay, example 3. So we have a diagram illustrated the problem of these questions. We have a functions y is equals to negative x cubed, and we have a region of AB accordingly. So now the question is express x in terms of y. Okay, soalan yang pertama kita nak kena express x in terms of y. Okay, and hence calculate the area of the shaded region. Dan kita calculate areas of the shaded region. Okay, so let's start with express x in terms of y. So we have y is equals to negative x cube. Then kita simplify ataupun kita express x in terms of y. Kita akan dapat x is equals to negative y to the power of 1/3. Okay, alright. So then in order to calculate for A, for region A, so area of A, okay, so kali ni adalah melibatkan function of y dengan y axis. So we are going to integrate from 1 to 2, okay, which is fy. So kali ni kita akan ada in terms of y. So negatif saya akan letak di luar. So y kuasa 1/3 dy. So this is actually for area A. And for area B, okay, area B, so the limit is actually from -1 to 0. Okay, so sama juga negatif saya akan letak di luar, because negative is actually a negative 1, which is y to the power of 1/3 dy. Okay, so let's calculate for area A. So dekat sini for negative saya keluarkan. Dekat sini saya akan calculate, saya akan dapat integrate of y kuasa 1/3. Saya akan dapat y to the power of 4/3 over 4/3. After simplify, saya akan dapat 3/4y to the power of 4/3. Okay, substitute the limit from 1 to 2. Okay, then daripada sini saya masukkan nilai. So saya akan dapat 3/4 kali dengan 2 kuasa 4/3 minus with so now 3/4. Okay, so then after calculating this dengan menggunakan calculator, saya akan dapat nilai dia iaitu 1.14. Okay, 1.14 unit squared. Okay, and then for area B, okay, so area B, so remember we have a negative value actually. So since we have a negative value, so dekat sini kita akan letak nilai modulus. Okay, so nilai modulus, so means that kita akan consider a positive value untuk area A tadi, sebab kita calculate area of the shaded region, so we only consider a positive value. So let's consider B, area of B. So we have integral of limits from -1 to 0 of y over y to the power of 1/3 dy. So sama juga dekat sini, saya akan dapat negative 3/4y to the power of 4/3 from the limits of -1 to 0. Then saya akan dapat negative of, okay, so negative of 0 minus with minus with 3/4. Okay, so minus will become so here saya akan dapat 1, negative 1, saya akan masukkan so 0 minus with minus with 3/4. So therefore here saya akan dapat positive of 3/4. Okay, unit squared. Okay, and then area of the bounded region. Okay, so area of the bounded region, so A plus B. Okay, sorry, so A plus B. So therefore saya akan dapat nilai 1.14 plus with 3/4, which is equals to 1.89 unit squared. Okay, so this will be a final answer, right?